Grandma has just finished baking a large rectangular pan of brownies. She is planning to make rectangular pieces of equal size and shape with straight cuts parallel to the side of the pan. Each cut must be made entirely across the pan. Grandma wants to make the same number of interior pieces as pieces along the perimeter of the pan. What is the greatest possible number of brownies she can produce? Let's first draw our rectangular pan. Let's say it has a length L and a width W. So we realize our condition here that's pretty important is that Grandma wants to make the same number of interior pieces as pieces along the perimeter. So that means the interior will have half the number of pieces as the entire pan. So therefore we have the entire pan has length times width. So that's the entire number of pieces inside. And we divide that by 2 is the number on the interior. We also know another way of saying this is we take one piece out from the left and the right, as well as the top and the bottom. So that's equal to width minus 2 times length minus 2. So these two are set to be equal to each other given this condition that Grandma wants. So let's do some solving. We realize that W times L is equal to 2 times W minus 2 times L minus 2. And we know that WL is equal to 2 times WL minus 2W minus 2L plus 4. So that leaves us with WL equals 2WL minus 4W minus 4L plus 8. Moving everything to one side, we have WL minus 4, W minus 4L plus 8 equals 0. So let's try to apply Simon's favorite factoring trick here to do some factoring. We have that W minus 4 times L minus 4 minus 16 plus 8 equals 0. Therefore, W minus 4 times L minus 4 is equal to 8. And we can try factoring out 8. So that can give us 1 times 8, 2 times 4, etc. We realize that the width is always going to be shorter than the length just by the conventional definitions of width and length. So we don't have to take care of the 4 and 2, 8 and 1 cases. So since we have our 1 and 8, 2 and 4 cases, we realize that when this is 1 and this is 8, W is going to equal 5 and L is going to equal 12. And then when W minus 4 is 2 and L minus 4 is 4, then we have that W is equal to 6 and L is equal to 8. So these are our two conditions. And since we want the greatest possible number of brownies she can produce, well, W times L is equal to 60 and W times L is equal to 48. So our greatest case is going to be this case with width as 5 and length as 12, giving us 60 brownies, which is answer choice D.